Okay, factoring using symmetry is used for polynomial with more than one variable. Sorry. For instance, let me talk about symmetry first. So this is a symmetrical polynomial, which means that if you change x to y, let me x to y, y to z, and z back to x, no, the polynomial doesn't change. For instance, let's do that here. Instead of x, put y, that would be y squared, plus y to z, that would be z squared. Z to x is x squared, minus 3, again instead of xy, instead of yz, instead of zx. Now this is equal to this. It's just, it's just rearranged. And for instance here, x, y, and z, none of them is better or worse than the other, let's say. Okay, but how to factor such polynomials? Let me give you an example. For instance, factor this. A plus B plus C times AB plus BC plus AC minus A plus B, B plus C, and A plus C. Okay, if you multiply this by this minus the result of this product, that would be a polynomial, and we want to factor this. Now, at one point here, let's first, this is a symmetrical polynomial, because if we change A to B, B to C, and A to C again, and C to A, sorry, that would be equal to the original polynomial. This would be again A plus B plus C, this would be again this would be B plus C, this would be C plus A, and this would be B plus A. It's just a rearrangement of the terms. Okay, now the point for the symmetrical, for factoring these symmetrical polynomials is that after factoring it should remain symmetrical. Okay, for instance, here let's have a guess that A is one factor of this, which means that A equals 0 should make this vanish also, because you know A is one factor of it, the rest, let's call the rest as G, and A equals 0 make this side vanish, so it should also make the original polynomial vanish. Okay, so let's check that. Here put 0 into A, would be B plus C times 0, 0, BC minus B times B plus C times C. Let's write this C here, or here, CB. So this is equal to this and is 0. So A is a factor of this, and because it is symmetrical, then B and C also should be other factors of that, because you know let's say A and B and C, none of them are better or worse than the other, you know. If A makes it vanish, B also should make it vanish, also C. So let's look for the other factors. Here we could do it by dividing this by this, but we could do better here, and that is what, you know, the degree of this polynomial is, you know, for instance, the terms of this is A, for instance, A squared B here, and from here we got the terms in this form also, which means that the degree of this is 3. You know, for instance, or we got terms like this or like this. So for instance, A times B times C. Okay, so the degree of this is 3, so the degree of this is also 3. So there is no other, you know, ladder factors or algebraic factors, but maybe we got a numerical factor here. Say, for instance, say n. So, but how should we calculate n? The best way is substituting some numbers into this 3 and also here, and find the n from there. Okay, let's substitute 1 in both in them. Okay, so 1, this would be 3, this would be also 3, 1 plus 1 plus 1. Here we got 2, 2 and 2. Okay, 3. Okay. Oh no. Okay, minus this and also put 1 into this, which is 1 also. So here we got 9 minus 8, which is 1, and here we got n times 1. So n should be also equal to 1. Okay, let's have another example. Okay, let's factor it. It is symmetrical. You could check that as a practice. Okay, but let's factor it. And first, let's find one factor of it. You know, if we put this to be equal to 0, this would be equal to 0. Okay, b minus c, if we put that to be equal to 0, b would be equal to c. So this is 0 here, and let's put c into b. Okay, the second one would be b squared, b minus a, and here b squared, a minus b. So here we got b squared here also. This is b minus a, this is a minus b. So this is the negative of this, and it's equal to 0. So b minus c is a factor of this according to the remainder theorem. Now, since it is symmetrical, so b minus c is a one factor as we derived. Then, since it is symmetrical, also a minus c, let's say a minus b should be factors of this. Okay, and you know, for the other factors, we could divide this by this, or we could do better. How? This is of the degree of 3. Okay, the terms of this are in this form. Say, or b squared c, something like that. Okay, and the terms of this also are in this form. For instance, here we got b times a, which is ba squared. So are possible. The other factor is a numerical one. Again, we could substitute some numbers into a and b and c in the both side and find the n. Okay.